we're going to form our first asset transaction. So on Algorand, assets are not smart contracts. They're just native functions of the blockchain. So on other chains, you need to make a smart contract in order to mint an NFT. On Algorand, that's not the case. You can mint an NFT with just the SDK. And it's done so with, still the decentralization of the blockchain and much more security and assurance than a smart contract. So in order to mint a asset, what we have to do is call make asset create transaction with suggested params. This is very similar to the payment transaction. We are sending some payload to the network to tell it to do something, except in this case, instead of doing a payment, we are doing an asset create transaction. And so in our asset create transaction, the first thing we want to do is pass in suggested params, like every transaction will be sending, specify who's sending the transaction. In the context of asset creation, this is going to be who is the account that's minting the asset or who is the creator of the asset. And the asset name is going to be my first asset. And this is the long name that will show on things like Explorers and on the ledger. And then we have our unit name. And this is basically the short name of the asset or the ticker name. And this is what's going to show on things like DeFi protocols and liquidity pools. So whenever you're transacting with the asset, this is what you'll see. Commonly, this is just an abbreviation of the asset name. And then we define our total, so how much of the asset we want to make. If you're making an NFT, you would simply just define one, and it would be a simply one of one asset. But we can also create an Algorand Standard Asset or an ASA with just one or with multiple, and that creates a fungible token. And so what's important to note here is that this is the amount of the smallest unit of the asset. And I'll be showing examples of how this actually looks visually once we actually send this transaction. But the idea here is you define a total for the smallest unit, and then a decimals for how many decimals are in that unit. So for example, here, I say I have 100 total units, and there's just one decimal place. So this basically means on the network, what the ledger sees is if I transfer 10, it's actually 10 divided by 10 because there's one decimal place. So it's just one. And again, this is going to be a little bit confusing just talking about it. So we're going to show you visually what this looks like. The main idea here is you have how much of the asset and how divisible is it. Once all this core information about the asset is defined, we have a couple other fields that we can fill in as well. And these are really cool features native to Algorand standard assets that are unique to Algorand and don't require smart contracts. So the first of which is the reserve account. And so this is an account that we specify that holds the uncirculated supply. So when you do an asset create transaction of 100, that's going to technically mint all 100 of them at once. But if you specify reserve address, any amount of that asset that you send to the reserve address is going to be considered to be unminted or not in circulation. And then we also have a freeze address. And this allows us to specify which account has the authority to freeze assets and accounts. So what this basically means is if I have an asset and I send it to someone and I don't want that person to be able to transact with that asset anymore, I can freeze it. That will make it so that they can no longer send that asset to anyone else. Now, this is a completely optional feature of Algorand. So if you don't want your asset to be able to be frozen, you can simply leave this blank. I've just filled it out here as a demo purpose. And if you have filled it out, you can later change it, which I'll go over in just a second. And our next property is related, default frozen. This basically just means when we mint the asset, will it be frozen by default? And this basically means, do we have to explicitly unfreeze the asset every time we want to transact with it? And so that's for asset freezing. Again, these are completely optional features. And then one other optional feature is the clawback. So this is similar to freezing, except instead of freezing an asset in an account, you can take back that asset. So if Alice creates an asset and sends it to Bob, she can then, Alice, without Bob's input at all, she can revoke that asset and send it to, let's say, Carol. So this basically means that a clawback address will always be able to transfer the asset on behalf of the holders. And again, much like our freeze asset, If we didn't want this feature, we would just leave this blank and no one would be able to call it back. It's a completely optional feature, but when we set this address, whatever address is set here, we'll be able to do those sort of unauthorized transactions. Finally, or second to last, we have our asset URL. And this is basically going to be the URL that contains more information about our asset. So for NFTs, this is commonly an IPFS link that has information about the attributes, the image, stuff like that. Here, I just put a URL to our developer portal, but this can be any link. It can be a IPFS link. It could be a HTTPS link. It just depends on the standard that you're following and how you want that asset to be represented. Now, finally, we have our manager account, and this is the account that can change all the other accounts in our asset. So this manager can change the asset, freeze, clawback, and it can also change the manager itself. And this will basically mean if you have a freeze account set, so if you set one account able to freeze assets, the manager can then change which account has the authority. Now, if the freeze is undefined initially, the manager can't set it after the fact. So if you have an asset on Algorand and that it can't be frozen, that'll be true for the entire life cycle of that asset. So that was the general information about the asset. But the context here is that we want to create this asset. So we're passing all this information into our make asset create transaction function. What this will do is it'll create an unsigned transaction. And much like before, we want to sign it. So we're going to call it .signed transaction. And we're going to sign it with our account private key. And then we're going to send a raw transaction, send it to network. We're going to wait for it. And then we're going to go to our algo D, and we want to figure out what the asset ID of this asset that we created. So here in this transaction, we're creating an asset, and whenever we create an asset, it gets a unique ID on the Algorand network. And so we want to ask the network what ID is the asset that we just created. So we're going to call AlgoD client and get transaction information of this transaction. So we're passing in our transaction ID to AlgoD, and then we're going to get the asset index from that transaction. So any transaction that creates an asset will have this asset index property, and this will contain the ID of the asset. So let me go ahead, going to hit enter to execute all this code. So it's going to send the transaction to create the asset. This is the transaction ID. And I can now see that the asset index here that I got from AlgoD is this 175 number. I can go ahead and take a look on the Explorer to see what this looks like. So I can see on the Explorer, we have an asset create transaction sent from our DX2 account called my first asset. This is our asset ID. And then we have all of our creator, clawback, freeze manager, and reserve addresses set. It's one decimal place. This is our unit, our total, default frozen, and our UL. So all the information that we specified in the SDK. And now if we go ahead and click on this asset, we can see that we currently have 0% minted and a total of 10. So let's go back, take a look at our transaction and see why we see that. So first, we have 100 total units divisible by 1. So this means if we have 100 divisible by 10 to the 1, that's a total of 10. And it's saying 0% is minted or 0 is circulated because we've defined our reserve address as this DX2 address. And this is the account. If we go ahead and look at the asset, it holds all of the supply right now. So that's why it says it's 0% minted. So now let's go back. Let's go ahead and transfer it to a new account. So we're going to create a new account. We're going to form a new transaction. This is yet another transaction type called make asset transfer. And this is similar to a payment, except instead of sending algo, we're sending an asset. So we're defining our amount as 25. And what this really means is 25 times 0.1, because we have one decimal place. So that's going to be 2.5. So in this transaction, because we have a total of 100 and we specify one decimal place, 25 is going to transfer 2.5 of the token. And then we need to specify our asset index so the network knows which asset to transfer. And then we're going to go ahead and sign it. And now you're going to see this try catch here. So what we're going to do is we're going to try to send it to the network. And it's going to throw us an error. So let's take a look and see what that error is. So here's the error. We can see here, receiver error must opt in. So this is one of the unique features of Algorand Standard Assets, these standard tokens that you can create on Algorand with our SDKs, that in order for an account to receive an asset, it has to opt in. And this basically means if I want to be able to receive an asset, I need to tell the ledger, hey, it's okay for someone to send me this asset. I want to reserve the space in the ledger for you to keep track of how much of this asset I have. So what opting in basically is, it's adding that asset to a whitelist on your account to say, I want to be able to receive this asset. So if you don't opt into an asset, you'll get this message and no one will be able to send you that asset. So in order to opt in, we need to do a couple of things. First, we need to fund this new account. So in order for an account to be on the ledger, so for any account, even if it initially has a zero balance, it will not be on the ledger. And what we need to do is fund it with 0.1 algo to add it to the ledger. If you don't have 0.1 algo, the account will not be in the ledger. And if you try to go below 0.1 algo, it will automatically tell you, hey, you can't send this because it'll put you below 0.1 algo. And so that's the account minimum balance, what we call the minimum balance requirement, or also called the MBR, minimum balance requirement, or MBR. So the account MBR is 0.1. And then for every single additional asset that we want to hold, we also need an additional 0.1 algo. So in our case, we're going to be creating a new account. So we're going to be providing it with the account MBR of 0.1. And then we also want to send an asset to the account. So we're sending an additional 0.1 algo. And so what we want to do is transfer 0.2 algo from our existing account to our new account. So that's exactly what we do here. We're going to do a make payment transaction, and we're going to set the amount to 200,000 micro algo or 0.2 algo. And here we're going to double our fee. On Algorand, we have this concept of atomic transactions. And this basically means send these transactions together to the network and only send them if all the other transactions exist and actually pass. And what we're going to do here is we're going to leverage the fact that we can pool transactions together and pool the transaction fees together so that our new account can send a transaction without actually having to pay a fee. And this is really useful for things like gasless contracts or common paradigm on other chains. On Algorand, our fee is just 0.001 algo, which is like 3/100ths of a penny. So it's fairly small, but it also helps reduce end user friction if they don't have to pay fees. So that's what we're going to do. So in our first transaction here, in our fund transaction that we're sending from our existing account to our new account, we're going to go ahead and double the fee. So we're going to get our suggested params. Then we're going to override the fee to be 2x Algorand min fee. As you can see here, this default value is 1,000, which is 0.001 algo. So we're setting our fee to 0.002. And then we're setting flat fee to true. And this is basically saying, make sure that when we send the transaction, this will be the flat fee that we're sending. Don't try to dynamically change the fee on the fly. And then down here, we're going to basically do the inverse. So we're going to set our fee to 0. But you might notice we're doing an asset transfer. And this is how we actually opt into the asset. I said in order to receive an asset, you have to opt in. This is what it looks like. An opt-in transaction is actually just a 0 asset transfer from one account to it itself. So in this case, I want this new account to opt into our asset. So I make an asset transfer. I say it's from the new account, it's to the new account, and the amount is 0. And then I pass in the asset index that I'm going to be transferring, or in this case, that I'm going to be opting into. And then I go ahead and override the fee to be 0. So now Algorand, we expect the fee to be 0.001. So now we have 0.002 here, 0 here. That averages out to 0.001. So the network will be happy with our transactions. And now what we can do is we can group these transactions together and ensure that the network sends them and groups them together. So what we're going to do is we're going to create an array of transactions. So we have our fund transaction, our opt-in transaction, and then the asset transfer transaction. This is the transaction that we tried to send earlier, but it failed. So we're going to go ahead and add it to our group. So we now have 3 transactions: funding the new account, opting the new account into the asset, and then transferring the asset to the new account. And then we're going to call algo SDK.assign group ID and pass in our transaction array. And so what this method does is it takes in all of our transactions and updates them to include a group ID, and then spits out a new array with all of our transactions for us. So now we can see we have this new array transaction group, and we can go ahead and sign them. So we're going to create an array of signed transactions and go through each of our transactions and sign them. Now, the important thing is that when we're signing transactions, that we make sure the signer aligns with the from. So for example, our first transaction here is this fund. So we're signing with our account. Our second transaction is an opt-in. So we're signing with our new account. And our third transaction is that asset transfer, which is coming from our original account. And so we're signing with the original account. And so now at this point, we have our signed transactions, which is a binary, which is an array of binary data. And we're going to go, before we send it to the network, we're just going to go ahead and record what the group ID is. So on any of these transactions, just go ahead and get our group property. And we're going to encode it to a base 64 so we can log it to the console. And then we're simply going to go ahead and send our transactions to the network. So earlier, we had a single transaction. We just sent that raw data to send raw transaction. Here, we have an array of binary data for transactions, and we can go ahead and send them all together. So you can use send raw transaction to send one or more transactions to the network. So that's what we do here. We send them to the network, and then we're going to wait for confirmation like normal. And then we can go ahead and see the group on our Explorer. So let's go ahead again. We're going to go up here. When I hit enter, it's going to execute code starting from this line here, then come all the way down, form those transactions, put them in a group, sign all the transactions, and then send them to the network. We're going to go ahead and do that. This is our base 64 group ID, which we'll see in a second. And there we go. And in 3.5 seconds, we've sent 3 different transactions to the network atomically. And we can go ahead and look at our atomic group here. So our first transaction here, which is at the bottom, is transferring that 0.2 algo from our first account to our new account. And then we want that new account to opt into the asset, so sending 0 of the asset to itself. And then we're transferring from our original account to our new account 2.5 of the asset. We can also see here that our fees, we paid a double fee here, 0 fee here, so these average out, and then just a regular fee here. So the total fee is 0.003, so the network is totally cool with us sending these transactions. If it was below that amount, then all of these transactions would fail. And if it was above that amount, then we would just lose out on that algo and the network would just take it. So it's important that you make sure that you're sending the minimum fee when you're sending transactions so you don't overspend on fees. So let's go ahead and take a look. We can now see, go back to our asset, that we have one holder, and that's this PW6 account. They have 2.5 of the algo, therefore 100% of the circulating supply. And we can see over here under minted supply, 25% is minted because we have this one account that has 2.5. And then the rest of the amount is in our reserve address. So if we go over here, assets, we have 7.5 here. So again, what we've done is we've created an asset with 10 total assets divisible by 10 each. And we've sent 2.5 to this new account. So we now have 2.5 in circulating supply. Okay, so that is assets and how assets work.